Hello folks, in today's lecture we are going to talk about exception handling. So exception handling is something that you as a human being do very well. You basically have this ability built in that if you're trying to chug through some particular thing that's happening in your day and something goes wrong, you can generally stop and think about it for a moment and decide what is the appropriate response to that problem. So let's take this example. You get in your car and you start driving down the street, and at some point the car just cuts out and you stop. Well, if your code, the code that's running in your brain, is for you getting to work, and the method was get in car, drive car, end up at work, then something has gone wrong at the time that the car just stalled in the middle of the road. So the question is, what went wrong and what can we do about it? Well, there's a couple of things that you can do about it. I mean, the first thing you might want to check is, did you run out of gas? So if you ran out of gas, the correct answer is probably pull the car over, walk to the nearest gas station, buy the little container of shame, fill it up with gas, bring it back to your car, pour it in, and away you go in your happy way. So that will be an example of an exception that you were able to handle. If the car catches on fire, that's quite a different exception that you will handle in a different way. Probably going and fetching gas isn't going to be helpful there. So maybe you might get your fire extinguisher if you have one, or maybe you run away from the car and hope that somebody else can handle it. Call the fire department. But you in your life are dealing with exceptions all the time. You wake up in the morning, you think that you're going to go down path A, and in reality, quite often you end up going halfway down path A and then something goes wrong and you go a different direction, and so on and so forth. So what does this have to do with Java and C#? Well, exceptions happen in your code as well. When you ask the user to enter something, you expect them to do what you tell them to do. If you say, please enter your age, you're expecting that they're going to type in a number between, well, probably 1 and maybe 120. Anything outside of that is probably not a valid number for age. If they type in 500, you have a lot of questions to ask. If they type in the letter B, it's not very helpful either. So these are exceptions. You asked them a question, you expected them to behave appropriately, and they did something completely different, which is pretty much what users are going to do. Up until now in these classes, we haven't really worried too much about these fringy conditions that could happen, but as of Module 6, which is what we're talking about here today, we are going to start dealing with exceptions. We're going to start writing more robust code where we are thinking through all the things that could go wrong, and we're trying to deal with those in an intelligent way. So we're going to start off with a little bit of keyword definition here. So we have 3 new keywords that you need to understand. These are the same keywords in both Java and C#, thankfully. So we have try, catch, and finally. And try is, if we go back to my example of driving to work, effectively when you got up in the morning and you had breakfast and then went downstairs, popped your key in the car or key fob or whatever it is, you then tried to drive to work. In the case where the car stalled, you would need to catch the fact that you ran out of gas and then have a subroutine that deals with the fact that you have no gas. You may also want to be able to catch the fact that you have a flat tire and deal with how to deal with a flat tire. You may also want to be able to catch the car is on fire, in which case, get out. So those are different types of things that you might need to catch along the way. Those are exceptions that could happen that you might want to write a routine for each of those circumstances. And so you would have one try, which was go to work via car, and then many catches for the different things that could go wrong. Other things that could go wrong that are not quite as catastrophic is you could get stuck in traffic. And if part of what you were trying to do was get there on time, maybe the catch routine is you call work and tell them that you're going to be 10 minutes late or whatever is the case. All right, so that's what try and catch do. You will have one try and you may have multiple catches around a block of code. You are trying to drive to work, that's one thing, and then you may have to catch 3 or 4 different things that could possibly go wrong. The finally keyword is used regardless of whether or not the try-catch happened. What does that mean? Well, sometimes you are going to get to work one way or the other, right? Whether or not you ran out of gas and whether or not you run into traffic. So when you get to work, there's a bunch of stuff that you're supposed to do at work, and that would tend to happen in the finally block. A better example in the real world or in the coding world is when you open a file, which we're going to see in the next module, you have to then eventually close the file and tell the operating system that you're done working in it, because only one person should ever really be editing a file at a time. So sometimes when you open the file, you may then want to make some changes in the file, and it may be that when you go to put something else in there, you may run out of disk space. which would be bad. But regardless of whether you did run out of disk space or didn't run out of disk space, eventually you need to close the file. So that's what would be done in the finally block. All right, so to review, around any thing that could be problematic, you would put a try block. You're trying this. Then you would underneath it have at least one catch that catches the particular thing that you're looking for, and then you would have maybe possibly more than one catch, and then eventually you would have a finally block. All right, so exception handling is an indication of a potential problem that occurs during the program's execution. You can resolve it without crashing. This helps you build more fault-tolerant programs, and it also makes your program more secure. How does it make it more secure? Well, it turns out that a lot of the security problems that we have in software are because people didn't think through things that could go wrong. And so I'm going to just break out of the slides here for a moment, and we're going to go take a look at an example of some code that could be potentially problematic. These are in my replit, so if you go to replit.com, which is their new address, /@endasullivan, you'll find a CSE 1322 exceptions, -Java and -C#. And that's the code that I'm looking at here, so you're welcome to go look at that. Don't worry about this -1, that's just because there's a real one there, and I'm currently working for the video with another copy of it, so there you go. All right, so here's a block of code that reads in some numbers, and then it averages the numbers for me, and it gives me back the average. Seems like a cool little piece of code. All right, so let's take a look at the top. So we're going to look through Java first. So I start off and I define the size of an array as being 5. I'm going to read these numbers in and I'm going to stick them into an array. All right, so the array that I'm going to put them in is something called num array, and so that gets a new array of max size, which is going to be 5, so 0 to 4. And I have an integer called current entries, which we'll see why that's here in a moment. We're going to skip over the two methods for a minute. We're going to come down to the main. Down in main, I call read numbers. So I'm going to zip up to read numbers, and that does nothing very exciting, just invokes a scanner, sets the input number to 0 for right now, just so I can go into my loop. And then I say, while the input number is not -1, print out, give me a number. If you want to stop, give me a -1. I'm going to read in an integer, and then as long as it's not -1, I'm going to add it into the array, and I'm going to keep track of how many entries I have. So basically, they're allowed to type in numbers until they give me a -1, at which point I will know that they're done. Once that method is over, it's then going to call the array average, or the average array method, which hopefully will return an average of the array. So if we zip up here and we take a look at this average array method, you can see here I start off with a sum of 0, and this is a very simple method. All I'm doing is I'm saying for I equals 0, I less than current entries, add the current entry into the sum, and at the end we're going to sum divided by current entries gets assigned to answer to return, which is a double, and then we're going to return that answer. So this should all work out great, right? I'm going to type in quiz averages. So we have an 80, we have a 90, and we have a 100. And then I'm going to do a -1 because I'm done entering in numbers, and my average is 90. Because if you add 80, 90, and 100, and you divide by 3, you will get 90. Great. Looks like this code is working great. Why are we looking at this code? Well, I'm going to run it again. And this time, I've decided, I have no quizzes. I'm just going to quit. Okay, so what happened? Well, you've seen this before, where anytime that your program has an issue, it's going to crash. And in Java, you're going to get something that looks like this. In C#, it's going to look pretty similar. So I'm just going to run the C# one again. The C# code is identical, by the way. So you're welcome to flip through it here, but it is doing exactly the same thing as the Java code was doing. So I'm just going to do a -1 here, and you can see unhandled exception, system divide by 0. Okay, why is this happening? Well, if we go back and we look at how I did my array average, I did for I equals 1 to current entries, which was 0. So this loop did nothing, actually, because there was no entries to average. So my sum was 0, okay? And then that's not a problem, except when I get to this line. When I get to this line, I said, take the sum, which was 0, and divide it by the current entries, which the current entries would start it off life as 0. So I said, answer to return is equal to 0 divided by 0. And as you know, you can't divide things by 0. That's a problem. So literally, my code crashed when it got to this line. And it says here, exception in thread main, Java lang arithmetic exception, divide, that's a divide sign, by 0, at main average array line 19, which was called from main line 45. All right, so what is the problem here? Well, I mean, I didn't give it a number and it crashed. Big deal. I mean, I should have given it a number, right? The user should have given it a number. The problem is that the program crashed. So anything that was happening before this is now lost, which maybe is not good, because maybe they had typed in all of their homework averages and maybe they had typed in all of the test averages, and it just so happened that the student hasn't taken a quiz yet, so they didn't type in a quiz average, and now your program crashed and all of that data entry has been lost. And they're going to have to start the program over again and run it all again. So at best case scenario, this is terribly inconvenient for the user, because your program should not crash. No matter what the user does to you, you should try to prevent the program from crashing. The second problem is, this is really, really ugly. Okay, picture your grandma or your grandpa and put them on front of this program and have them enter in stuff. And I pick on grandparents because, well, in general, grandparents don't know, they're not comfortable with the computer a lot of the time. And so they're okay with doing stuff in the computer until something goes wrong, and then it's like, oh my God, it went wrong. What is happening here? So this is an example of not being very user-friendly. This is a horrible experience for the user. They did what they thought was correct. I mean, it said enter a number, -1 to quit. I want to quit, so I typed in -1, and now you're yelling at me and telling me that an exception has happened, and what have I done, and a bad person, sit in the corner. And as you can see, the C# one it's even a little bit worse than the Java one. Unhandled exception, system divide by error exception, attempted to divide by 0 at main class array, average array, and then 0x00022 in A67. There's all these memory addresses. There's all these lines of code where it's telling me exactly where this happened. That is awful. As an end user looking at that, I'm like, I don't know, bad things happened. So that's not the experience that you want your users to have. All right, so how do we fix this? Well, we've talked about the try and catch, so let's try and do that. So right here where I have my original line where I'm calculating the average, I'm taking the sum and dividing it in there. So what I'm just going to do is I'm going to wrap this in a try catch. So I'm going to say try, and we're going to do that. All right, and then I'm going to put in a catch. And what I'm going to say is exception E, and I'll explain all this in just a moment. System out print line, because I am in Java here. You can't divide by 0. Okay, that's not very user-friendly. Let's try something nicer. You must give me at least 1 grade. Now, you can see that Java is underlining the return, and that's because there are certain circumstances where this could no longer actually get set. So if I type in -1 on the very first try, the answer to return is never set, which is not good. Java does not like it when you try to return something that could not have been, or that could have been not initialized. So I probably need to set it to something, even in this block. I'll set it to -1. We'll decide that -1 means that, or actually I'll set it to 0. We'll decide that the division of 0 by 0 is now equal to 0 because I said so. All right, so now we're going to run this code again. And in here, what I'm going to do is the exact same thing I did before, which is I'm going to put a -1 in. And you notice now, this is a lot more friendly. I'm no longer seeing this big error message. I'm just getting something that's a little bit cleaner and hopefully a little bit more informative to the end user. Just to prove that this is all the same, I'm going to do the same exact code here. This is in C#. And what did I write? I wrote, you must give me at least 1 quiz grade. And we'll copy that, paste that over here. And then answer to return is going to be equal to 0. And clearly I forgot a semicolon. All right. Okay, and I'm going to do -1 here, and it gave me a nice output. Okay, so Cool. Is this how you always do exceptions? Well, sort of. I mean, this is the absolute most basic way to do it possible. There are a couple of things that you can do in addition to this. So let's talk about what's actually happening here. So when I put this try block here, there can be more than one line of code in here. There actually would typically be more than one line of code. You don't want to write a separate try block, try catch for every single line of your code. That's going to make things very awkward. So usually what you do is you wrap the try around a block of code that you think is going to be problematic, and then you catch all of the things that could go wrong in that block of code. So I'm not saying you can only have one try catch. You can have more than one, but you wouldn't want one on every single line of code. The second thing is the way that I caught it in both languages, I caught something called exception, and I put an E at the end of it. Is that magical? And the answer is no. I can come back here. The E is just a variable name. It could be Bob, and that will work just the same in both languages. Now, you might say, okay, so this is a variable name. Of what type is this variable? And the answer is it's a variable of type exception. It's an exceptional variable, you might say. All right, so Bob in this case is actually an object that I get access to when I have an actual exception that fires. So for example, I could print out the content of Bob. So down here I'm going to say system.out.println. I'm just going to do Bob. I'm going to try and do Bob. There we go. And I can do this in both languages. I'm going to come up here. As a matter of fact, you'll notice that Java didn't give this warning, but in C# it said, you declared a variable of type Bob and then you never used it. That's a little bit weird. What are you doing here? So it was a warning, not an error. You're certainly welcome to not use it, but here we are. And then E was, no, it's not E, it's Bob. Is what I'm going to print. So let's see what happens here. Over in Java, I'm going to do -1, which causes it to happen. And you can see here in Java, that print statement that I just added that prints out Bob, it now is returning Java lang arithmetic exception divide by 0. So it's telling me the error that I'm causing. And over here in C#, it's going to do similar, but it's going to be a little bit more ugly. It actually gives me, again, more detail. The C# output is more detailed. So how is this happening? Well, as you know, any object that you have in Java, you can print it. And what will happen is the toString method will be fired in that object, and it will do whatever it is told to print out. So in the object exception, there is a toString wrapper that or a toString method that effectively prints out this particular block of code, which includes a memory address and some other stuff. And you have the same thing over here in Java. So you can print that, you could grab it and put it somewhere. It would be not uncommon that you would put that into an error log of some form. There might be a file that this program generates where it keeps track of all of these exceptions that have happened, and that might be a time where you would want to record that. So it's just a variable that has details about the exception that you can certainly take a look at and decide what it is that you want to do. All right, so let's come back over to our slides here and let's zip through a few more slides about exceptions. So I mentioned here that this can be used to keep your program a little bit more secure. Why would there be a security concern? So as I mentioned, when you're writing code, one of the most common things that people do is that they make a mistake and they don't really pay attention to what's going on from the user's standpoint. In my code, I set a variable equal to 5 at the very beginning as the size of this array. Hopefully that's setting off some alarm bells in the back of your head, because effectively I'm allowing the user to enter in as many numbers as they want until they give me a -1, but I'm storing them in an array that is only built to hold 5 things. So, of course, I think you can see that beyond the problem that we just fixed, which is the divide by 0 problem, there's a whole other problem here. I'm going to give you 100, 90, 80, 70, 60, and when I type in 50, I get another problem. This time I get an array index out of bounds exception. Index 5 is out of bounds for a length of 5, because when I tried to put that last number into that array, remember the array was defined as size 5, it was defined as an integer array of 5. Therefore, it has cells 0, 1, 2, 3, and 4. I filled 0, 1, 2, 3, and 4, and now I'm trying to put something into cell 5, which does not exist. Now, How is this a security problem? Well, the problem is that it attempted to write that in there, and then it gave me an error. I can now tell as a user that there is somewhere in this code where there is an array defined that is 5 cells long, and I can tell that right now you're not catching the fact that I could try to put a sixth thing in there. The language crashed and the program exited in this circumstance. But just knowing the internal details of your code now, even without being able to see this code, I can tell that that array exists, I can tell how big it is, and maybe there's another way that I can exploit it where I might be able to try and access a memory address. As a matter of fact, one of the most common security problems that you have in code is being able to write to an area of memory that you're not supposed to be able to write to. It catches that if you try to do it with an array by catching an index out of bounds. There are certain other circumstances where you can put something in an array cell that doesn't really exist, and that will cause you with all kinds of security problems. So my point here is you should not leave your code like this where an error could happen. If you're allowing the user to give you input, you need to be very, very careful about that input. If you're only going to be able to store 5 things, you need to check that they don't give you 6 things. Don't rely on the user to only give you 5 things. This is not a good state of affairs in your code. The correct answer would be, after they give you the 5th thing, you say, that's all you can give me, and you stop asking for new things. Or, if you're going to allow them to enter it, then you gracefully catch this circumstance where they're trying to insert it into the 6th cell, or the cell number 5, which is the 6th cell. So how would we do that? Well, up here is where, not up here, down here, when I'm reading in the numbers, this is where that error occurred. You can see that that is line 44. And again, this is my read number method where it's asking them to keep entering in stuff over and over again. I'm already keeping track of current entries, so the simplest solution really here would be, while input number is not -1 and current entries is less than 5, then continue through the loop, otherwise jump out of the loop. But you could also do this with a try catch. So I could certainly come up here and say try, and in this case catch, and I'm just going to do something slightly different. Array index out of bounds exception E, and in here I'm going to system.out.println too many, and then I'm going to set input number equal to -1. Now, why am I doing input number equal to -1? Because that's what's eventually going to stop the loop. I don't want to allow them to keep entering them and keep triggering this same condition over and over again, because, well, that's also a bad user experience. Don't do that. Still, don't do that. Don't do that. Don't do that. Your program shouldn't be very preachy like that. All right, so now we're able to enter 70, 60, and now here's the one that should cause the error. And this time I get an exception in thread main Java array index out of bounds. That is on line 17. Why is that on line 17? Because I still incremented current entries no matter what. Okay, so only if that succeeds do I want to set current entries. Okay, I'll just do it this way. If input number is not equal to -1, because I just set it to -1 up above, then I will increment my current entries. Okay, so to be clear, the problem here is that I was incrementing the current entries either way, and then when I went to do the average, it's using the current entries, and it was still trying to access cell number 6. But now that shouldn't be the case. 100, 90, 80, 70, 60, and this time we didn't get the awful error, we just got the word too many. And that's because I caught the error and I was able to successfully do the right thing, and the program exited like it was supposed to, and life is good. So I correctly caught the error. All right, so this is the idea of exception handling. It's very important that you do this, that anytime that you have code where you're allowing the user to do something, give you code, that you check to make sure that what they're giving you is reasonable. So here's another couple of examples from the slides. A simple block of code, we're asking them to enter in a number 1 and a number 2, and then we're dividing number 1 by number 2. Anytime that you are dividing two numbers, somewhere in the back of your brain, there should be a little flag that comes up that says, uh-oh, we have to check for exception. handling here because we could have a divide by zero error. It's very, very common to have that circumstance where they didn't give you anything and therefore you end up dividing by zero. So just make sure you always check that, right? So what if num2 is 0? Here's another block of code. And again, what's happening here is that we're taking in an array and we are asking them which element would they like to see in the array. But we're just asking them which element, and of course they're allowed to type in any number. But what happens if they type in 60 and the array is only 50 long? That's really bad. You need to catch that exception as well. Okay, so an exception is something that happens exceptionally. That's why we get this word. It's not something that's going to always happen. Most of the days when you drive to work or drive to school or wherever it is that you're going in your car, you get there successfully. Yay! And no exception happens. You don't run out of fuel all the time. You don't have a burst tire all the time. You don't have cars catching on fire all the time. There is the normal path that you would expect your code to go through, which does not have exceptions. Then there is a separate path where you deal with the exceptions that might have to happen. All right, so we have potential to divide by zero. We have potential to access memory outside the bounds of the array. There are lots and lots of other things. Each of these has a particular name of the type of exception that it throws. And as I say, here's your typical try-catch block, but on this slide is the names of the different things that you have. This is different in Java and C#, but the concept is the same. I'm just going to move this window up a little bit. No, I'm not, because it has decided it can't move up. Okay, well, then there you have it. Can I move over there? All right, that's better. Okay, so at the root of all objects in Java, we know that we have an object called object. Underneath that, there is an object called throwable in Java. And underneath that, there are three objects. It's not very obvious from this chart. There is error, and there is exception. I'm sorry, I said there were three, there are two. Error and exception. Underneath error, we have out-of-memory errors, stack overflow errors, and linkage errors. And underneath exceptions, we have runtime exceptions and I/O exceptions. Under runtime exceptions, we have illegal execution, illegal argument execution, index out of bounds, arithmetic exceptions. Then we have number format exceptions, array index out of bounds exceptions, and under I/O we have file not found and socket exceptions. We're going to deal with all of those in next week's lectures when we're talking about file I/O. But over here you can see this is a swath of different types of things that can go wrong. And you've already seen arithmetic exception, which was when we were trying to divide by zero. You've also seen an index out of bound exception. In C#, this is the equivalent chart. I'll just move back over to the other side of the window here. And so again, the root of C# is object, and then underneath that there is something called exception, and it indeed has three things underneath it. We have the I/O exceptions, which are over here. We have the application exception, and then we have system exceptions, which has all of these things in it. And again, you can see the various different things that we looked at. Such as arithmetic exceptions, which can be divided by zero, and we have overflow exceptions and so on. All right, why am I showing you this chart? Why does any of this matter? Well, the answer is that these charts show you the different kinds of exceptions that can happen. So if you remember back to the GUI class when we were talking about GUIs, we said that when they click a button on the screen or when they move their mouse and do something, there's lots of different things that can happen, lots of different events. So there can be a mouse that moved over something, there can be a mouse that was clicked, there can be a button that was pressed on the keyboard, they can start dragging and dropping, they can start scrolling. These are all different events that can happen. Well, likewise, in the exception world, there's lots of exceptions that can happen, and each one of those exceptions is an object. And so when you catch an exception, what you're actually doing is you're catching it and you're putting it into some variable that you then can interrogate to figure out what happened in there. The root of both of these is exception, which is right over here. And so you can see that in our code that we were writing a moment ago, we said catch exception, which means that in that block of catch, it will catch any kind of exception that is underneath exception. So for example, if you have a runtime exception, okay, does that allow me to draw? So if you have a runtime exception, which could be something like your arithmetic exception, notice that that does indeed connect up here, then that is inside of exception. So the reason I bring all this up is because just like any other object hierarchy that we might look at, if you catch exception, you're catching all exceptions. If you catch runtime exception, you're only going to catch runtime exceptions. I/O exceptions will not be caught by that. If you catch arithmetic exceptions down here, then only arithmetic exceptions will be caught. All other types of exceptions will not. And this is why you may want to have multiple catch blocks. You may have a catch block that deals with arithmetic exceptions, which is one catch block and you do one thing in there, and then you may separately have another catch block that deals with the array index out of bounds exceptions. Again, if you go back to my car example, when you were driving down the road, what you will need to do if you run out of gas is quite different than what you will need to do if a tire goes flat. So you will handle those as different blocks, different catch blocks. So in the code that I wrote, I caught, the first time around, what I caught was, how do I make this not be, there we go. In the first time around, what I caught was the general exception, which will catch any kind of exception that happens up here in this try block. But I could have been a lot more specific, because the particular thing that I really wanted to catch here was arithmetic exception. Arithmetic exception, there we go. And that can still be called Bob, and that's fine, but now it will only fire. So let's do a second one down below, which I'm going to say, in this case, catch exception. Call this one Fred. You get that these names are completely irrelevant. And I'm just going to change these print statements because we're going to be proving an answer here, or proving a point here. All right, so up here, I'm going to change these print statements to I caught an arithmetic exception. Excellent. All right, I'm going to run my code, and I am going to cause this same exact problem. I'm going to put in -1, and you see that I caught an arithmetic exception. So you may be wondering at this point in your head, well, how does it know which one to do? And the answer is, it will do the first one in your code that matches. So an arithmetic exception is an arithmetic exception, therefore that one was pretty clear that we were going to get the very first one. If I reverse the order of these statements, so if I come down here and I move this catch up above here, and they're now written like this, notice that now my code is actually going to return an exception, not an arithmetic exception. Has already been caught. Okay, line 29. Okay, well actually, all right, it won't even let you do that. So it's noticing the compiler is being nice to me and telling me you're being an idiot. What would actually happen if it would allow me to compile it is that this is what will always fire. And the reason that the compiler is noticing is it's saying, you have written a whole other set of code for what you want to happen with an arithmetic exception, but based on the way that you wrote this, that's never going to fire because everything will match exception. So let me be clear. When you say try catch, it is going to read the catch statements literally in the order that you put them in the code. The first one that matches the exception that has been thrown is the one that will execute. Since the first one that I have here is for exception, which is at the root of all of these errors that you can have, or all of these exceptions that you can have, then every exception that could possibly happen is caught by exception. And that's because, again, looking at this chart, all of these are underneath exception. So there is no point in having another arithmetic exception further down. If I reverse the order of these again, then if I get an arithmetic exception, it will fire this block of code. But if I got an index out of bound exception, it will fire this block of code because that is an exception, it's just not an arithmetic exception. Okay, so, and that's because of the chart. Array index out of bound is not a child of arithmetic, so therefore, when the array index out of bound exception happened in this imaginary world, which of course is impossible because there's nothing in this try that could ever fire an array index out of bound exception, but presuming through some level of magic it is possible for that to happen, then it won't match here, so it will move on and try this one, which it will match because array index out of bounds exception is a child of exception. All right. If we zip over to our, What is happening? If we zip over to our other C# window, our C# list, then the same thing would be going on here. I can just catch exception, which is at the top, or I can catch system exception, which is further down, or I can catch arithmetic exception, which is a child of system exception, which is a child of exception. So depending on the order that you write the catches, different ones may fire under certain circumstances. Most likely, you would have exception at the very bottom, which is the catch-all for anything that could go wrong in your code. All right? So when a problem occurs, it's going to, in the try block, it is going to throw an exception. At that moment, the execution of the code is going to stop immediately on that line. What do we mean by that? Well, if there were multiple lines in here inside of this try block, then it's not going to continue doing the rest of the try. The moment that the exception fired, which was on this line, it stops and then it goes down and tries to deal with the catch. Any other code that was in this try will not get executed. So if you need all the other code that's in here to also execute, even if the catch happened, that's where you would put a finally down at the bottom and do it in the finally. The finally happens regardless of whether the try catch happened or not. Let me say that again. If you have two lines of code here, int x equals 7. For some reason, I'm setting a variable to 7. And I need this to happen regardless of whether this is successful or not. This code should not be here. It should instead happen in the finally. And there's a problem with that as well, but let me be clear as to why I put it down there. If this causes an exception to be thrown, meaning the arithmetic exception happens because they don't give me anything and I try to divide by 0, the execution of the program stops here and it jumps immediately looking for a catch. This catch will then fire because that has been an arithmetic exception has happened. It will do this, and then it will go down and do whatever is in finally. But you can see that if I had not put this x equals 7 in finally and I had just left it up here, it would never happen if the exception is thrown. If the exception is not thrown, it would have happened, but that's not good code because you can sometimes have an x that's equal to 7 and sometimes not have an x that's equal to 7. So hopefully that makes sense, and if not, go back and rewind because I did explain it. All right. After the exception is handled, program control resumes after the last catch block. All right. If nothing happened, if an exception was never thrown, then the catch blocks will never happen, and after it, it continues after that. So it's kind of like an if-then-else statement, sort of. The if is effectively the try block. The then, there isn't really one there. The else is the catch blocks. And then at the end of it, finally happens regardless of whether you did the if or the else part. That's one way to think about it. You must have at least one catch if you have a try. You can't say try and then not explain what's going to happen, and I think that makes sense. You can have more than one catch block. We've said that before. Only one catch block will ever execute, and it is the first one in order that matches the particular exception that was thrown. The order matters. We've talked about that. And usually you have the generic exception at the very, very bottom. So here's an example. Catch file not found exception, do one thing, otherwise catch exemption, and that will handle everything else that is not a file not found exception. All right, the finally block is your cleanup block, and it, as I said, is going to happen regardless of whether the try catch happens. So here's the syntax. You're going to have a try block. You're going to have at least one, but potentially many catch blocks, and then you may or may not have a finally block, which is going to happen afterwards. Don't put a try block around every statement. That's just really ugly. Just make it into a block and do the try in there. It's better to place one around a significant portion of code, and separate try blocks should be used when it's important to distinguish between multiple statements that can throw the same exception. Okay, so that completes this video where I have explained to you how you catch exceptions that are going to happen as you are running through your code. You should get in the habit of catching all exceptions that could potentially happen as you are coding. You need to be very careful, especially when you're dealing with user input from a file, which we're going to see very shortly, input that's coming to you through a control socket like an internet socket or anything like that. because that's effectively user input. So you always want to be suspicious of your users. They are going to give you the wrong answer, and they're going to do the thing that you really, really hope that they don't do. So hopefully this has explained try and catch. You are hereby required to write try and catch blocks around any time the user might mess you up, and your programs should no longer be crashing. They should now be outputting appropriate error messages when exceptions happen. So there's going to be another video here in a moment that we're going to look at how to throw an exception, which is a slightly different circumstance. See you.